And welcome everybody to the Daily Space Weather. Today we'll be talking about coronal mass ejection unfolding as we make the video. Electron fraud. Yes, electron fraud. More sunspots. And Aurorae? Yeah, there's some Aurorae. By the way, I'm your host Dan, aka smAsho. Thanks for tuning in, viewers. First thing we're going to do is take a look at the sun in 335 angstroms. One of the ionized UV emission spectra, ionized iron UV emission spectra. These are the frequencies of light that certain ionic states of iron emit when heated up to very high temperatures. Sunspot 2784 here in the northern hemisphere. Sunspot 2783 down here. And another sunspot looks like it's rising right there. Again, we've got coronal mass ejections. We'll tell you momentarily if they're Earth-facing. So next thing we're going to do is we're going to go out to Lagrange point 5 to stereo A, which is viewing the sun in this orientation right here, to show you the trajectory from that perspective of the coronal mass ejection. And right at the end of the movie right there, just kicking off a few hours ago here, and it's not done unfolding yet, so this is something to keep an eye on. And when I say eye on, well, the pun is intentional. Now heading back to Lagrange point 1, which is where things like the Discover and the SDO are located. Let's go check the view from there, and here's the coronagraph on the SOHO spacecraft. And you can see some ejecta coming out of the east, none coming out of the west, an indication that that ejecta will miss the Earth to the southeast, or to be more precisely, the east-southeast. Again, there could be quite a bit more ejecta associated with this event here, and this event might not eject all of the coronal plasma, and there's a bunch still suspended out there at the time that this coronal mass ejection happened. We've got some great helioviewer movies. By the way, this is the kind of orbit the SDO takes. Figure 8 pattern with the crossover at the equator. The 10.7 centimeter radial flux has gone back up to 85, and no surprise as we see two significant sunspot groups and one rising. There's the 1-year chart of the radial flux. Next, looking at the auroral oval here, and we see some significant auroras kicking up. We are in the state of geomagnetic unrest as we made the video. So you can see significant auroras here over Iceland, Norway, Sweden, Finland, and now over Canada. And making it down to some possible aurora sightings there down in Minnesota. Most of Alaska likely to see some auroras as well. So here's our first helioviewer movie. And you can see that ejecta there on the east. And it does appear to be associated with that active region rising in the southeast once again. We did see some B-class X-ray flares as well. We'll show you that in a moment. Next, looking at a close-up here of the sun in 304 angstroms. And a great view there, courtesy helioviewer.org. Quite a bit of activity down there, and again, there could be quite a bit more coronal mass ejection. And likely another sunspot rising. Here's the same time frame in 193 angstroms. Still some coronal hole feature there in the Earth-facing zone north of the North Pole at about 50 degrees north latitude, ahead of sunspot 2784. By the way, thanks to all of our viewers for the kind words yesterday, sharing the comments, sharing the posts. Thanks everybody who answered the poll about the U.S. presidential election. If you haven't done so, check out our community post. Like and subscribe over on YouTube. Press the notification bell. Give us a thumbs up. Leave us a comment. And again, we thank our viewers for the recognition we received yesterday. Great view of that rising region there. Most assuredly a sunspot. There is a lot of activity associated with that. And there is a chance for significant solar flares here and coronal mass ejection associated with 3 different sunspot regions here. I can't call that yet as I don't see an umbra. But here's the view in 171 angstroms, and it does indeed look like that B-class solar flare came out of that rising active region. And once again, I would bring up the Earth-facing quiet effect. Does anybody have any idea how it works? I can't even tell you who does know how it works because, well, I could give it away. And as of now, it's remaining a proprietary secret. Intellectual property of smAsho.org. Fantastic view of that. And here's another zoom out here, the full disk view in 94 angstroms. We've got a lot more data to blast through and other stories to talk about. So we don't want to spend too much time on it. Let's get moving. And we'll probably make at least one more video today. And welcome to the Smash Lights segment. Now, during the Smash Lights segment, we're known to go against the flow and talk about whatever we want. Today, we're only going to talk about smAsho.org and smAsho.com. If you haven't checked out the websites, please do so. Our social media links are there in the upper right. Click that arrow. You see that drop-out drawer. We've also got 7 smAsho.org Presents the Sun videos on there, as well as links to the forum and 2 different stores. Check those out. Today's featured product is the Mansa shirt. Yes, I'm wearing one now, just like the one you see on screen. Mansa. Make America not suck again. It's up to you, not the government. What a ridiculous idea that the government's going to make America not suck again. With massive amounts of waste, fraud, and abuse, it's up to you to make America not suck again. Perhaps pick up one for your friends or foes for Christmas. Or perhaps pick up an Are You Safe Yet mask. Yes. Are you safe yet? This is the message I want to convey to people when I'm in public. Do you honestly think that you're safe because I'm wearing this mask? Really? Check out our Discord server also, as well as all of our other social media. Again, it is all linked at smashomash.com, official website of the Smash News Network. A location that is not yet, not currently on fire. And thanks to all of our patrons and so on, smashomash.com. Find all of our links, etc. there. If you don't follow me on Instagram, you may not see posts like this.
It's the new batch, and it's moist.
It's the new batch, and it's moist.
New batch.
So if you haven't seen that, there's also a recipe for that, but you'd have to be an Instagram subscriber to see it. I know you may not like Facebook. Nobody likes Facebook. Facebook is a piece of crap. And again, if you enjoy the content on YouTube, please press like and subscribe over here. Again, we've got a community poll here. We'd like people to respond as to whether or not how they would react if 7 million votes were overturned, not valid, fraudulent, etc. Not with respect to who they're for, but just not being valid. So we've also made some changes. Visit the links. There's a bunch of links there. YouTube.com/smashomash. Also check out our playlists. We've made some revisions. We're almost at 250 subscribers on BitChute as well. Don't forget to check us out there, as there is exclusive content on all of our social media. We're also on Facebook. There's a group called Entropy Busters. We're also on smashomash.locals.com, Dave Rubin's news site, and it is glorious, by the way. It's absolutely lovely. The way that it's built is fantastic, and if you're running into problems with Facebook censorship, you can create your own community over at locals.com, where you make the rules and you decide pretty much everything that goes on. We're also on alternative tech such as minds.com/smashomash. We're on Twitter, which is far from alt tech. We do most of our live streams on Twitch, today not. And we're also on gab.com/smashomash. And there ends today's Smash Lights segment. Today we're not going to talk about cosmology at all because there's too much stuff to cover, and, well, frankly, Smash staff and I slept in. So the next thing we got to do is thank our patrons, the true source of funding for the content. Thanks, patrons. Please consider becoming a patron at patreon.com/smashamash. Leave us a comment what you think about the ringtones that we've been uploading, and look for that to get more and more sophisticated and more interesting. We're doing simple ones now. We'll be doing much more complicated ones later. You can get ringtones if you become a patron. There are 9 tiers over there. Patreon.com/smashamash. Again, no cosmology segments today. Let's get back into data. The real-time solar wind is now before you. So, we see a strong coronal hole wind stream just arriving. That's what's causing the geomagnetic unrest, and the solar wind speed is over 600 kilometers a second, which is quite high. And we see the basic signature here of a significant strong coronal hole wind stream arriving. Very normal for a coronal hole wind stream. The density spikes, gradually comes down as the velocity comes up. So there you go, standard issue coronal hole wind stream, quite strong, and we would expect that to last a solid 24 hours. We may even get into geomagnetic storm conditions as the solar wind speed is a little bit higher than we would have anticipated. Current solar wind density around 9 kilometers per second. Current solar wind speed just coming off of its highs here at 591. And the highest we saw was around 634 I saw there. 634 is the highest one I can see. And there you see that geomagnetic unrest over the past 9 hours. Today we're going to show you 3 panes of geospace magnetosphere movies. For some reason the ground magnetic perturbations map is not working. It's only showing us a still image. So here is the geospace magnetosphere movie showing the velocity of the incoming solar wind. Next we'll look at the density. And we see quite dense regions surrounding the planet here shown in dark blue, low density regions shown in white. That is an increase in earthquake probability, and we did see an uptick from yesterday. Still no major quakes, as the 7, 8, and 9 magnitude earthquake drought, and indeed 6 magnitude earthquake drought continues, although we did see a 6 magnitude quake over the past 24. And here's the magnetohydrodynamic pressure, and you can see quite high pressure sparking off significant auroras around the planet. And that's 4 hours of data courtesy University of Michigan. Here is the ground magnetic perturbations map. And again, it's not showing us any kind of an animation here. I don't know what's going on with it. But there you can see significant magnetic perturbations happening here in the southern hemisphere especially, also in the northern hemisphere. And you can sort of see the location that there are sort of 2 different poles there in the northern hemisphere in this image. It's a good image for that. There's the global view. And we do see some magnetic pulses coming out of the Pacific Ocean there as well. Next, looking at the proton flux, we don't see any real major spikes in the proton flux here. And this is density, so you're looking at particles over space, so that's density. And there's that small B-class solar flare that we saw kick off there a few hours ago. Nothing to write home about, and it came out of that active region, not out of a named sunspot yet, it looks like. Here is the star chart, as I'm always interested to know what's going on above my head. That's for all of you astrologers and stargazers. Where will you be when Deneb rises? Well, it's just risen. Probably a half an hour ago here. Deneb, the brightest intrinsic object visible from our solar system, yes. A Wolf-Rayet star and a massive orbiting little companion. And by the way, it orbits at a period of about 4.8 hours. Here's what's going on in the solar system. There's what we expect to be going on in a week. And here's the continued spikiness on the GOES magnetometer. So you see these wild rides here in the GOES magnetometer. That's been forecasted. And when there's a bunch of plasma in between the sun and the earth, it causes these variations. It all has to do with the magnetometers not being able to read the solar magnetism and basically having the plasma steal energy from the magnetism to be heated up and oriented to the magnetic field lines. Here's a top view ecliptic plane field plot. Now we're looking at the heliosphere and the polarity of the current sheet. So here's the current sheet, North Pole shown in green, South Pole shown in red, and will remain in the North Pole current sheet for the foreseeable future, especially with that large active region rising. And again, I would remind you that the coronal mass ejection that we're watching right now is still unfolding and not complete yet. Significant likelihood of more of that happening throughout the day. Here's the coronal hole field plot from the line of sight perspective. And all this data is part of the National Sunspot Observatory. It's based on over 50 ground-based magnetometers and one on stereo A and stereo B. The magnetometers on stereo A and stereo B and 51 ground-based magnetometers are how this data is compiled. And here's a line of sight field plot also showing the Z fields in green and red, North Pole and South Pole respectively. And last but not least, a field plot of the corona. And it's kind of all over the place, not really a surprise there, as coronal mass ejections have been kicking off the past 3 days. And so you can see those field lines are quite disorderly looking. And this shows you open potential field surface source lines in black or purple and closed potential field surface source lines in pink. Next, looking at electrons, here's a diagram of the Earth's Van Allen belts. We show this daily to give people an idea of sort of the distance, and you can see the SDO there located at about 22,000 miles. And it also does show you the locations of the inner and outer Van Allen belts. We do see some charging hazards, surprisingly here, despite quite low levels of electron flux. Here's the 1-year chart. You can see very low levels. And we're expecting an increase here. I would delay this. I would say this increase is not going to happen until after the coronal hole wind stream ends, but we'll see if NOAA is correct. There's a 3-day chart of the electron flux, and you can see very low levels. Next, looking at a visualization of the air column here to see significant anomalies, especially over North America and Canada once again, as well as nighttime anomalies around the equator area. This shows the whole air column electron content all the way from the thermosphere down to your potential GPS handset rather. Next, we'll look at the ionosphere layer, and we immerse our viewers in the data daily to attempt to show the physics of how these variables relate. As we're not interested in ridiculous theories, we're interested in the actual physics of how things work. Part of the reason why we make the content. So here's the F2, the Ionosphere Map, and it's pretty anomalous here. And no surprises there, as we see anomalies in the electron flux as well. Here's the latest image coming in pretty late at 12 o'clock Universal Time. That one's looking normal at the moment. Next, we're going to look at volcanoes. What's been going on over the past 24? What's been erupting? Getting a little closer to home here, Kluchevskoy is erupting. It's producing a 20,000-foot ash plume. Suwanosejima is exploding, producing a 6,000-foot ash plume. Ibu's exploding, 7,000-foot ash plume. Dukono, similar situation there. White Island has been going and has been erupting in an ongoing fashion, with ash emission and a steam plume. Revenador exploding, 16,000-foot ash plume there. And Sabancaya has upticked a little bit here as it explodes. A 28,000-foot ash plume is nothing to pole vault. Please do not do so. Largest quake of the past 24 was a 6+ magnitude in, South America. We saw a bunch of deep quakes kick off yesterday and the day before. Here's a 4.7 that kicked off yesterday at nearly 180 kilometers at the Philippines. A deep quake at Afghanistan at a 4.3 magnitude. Another deep Philippine quake. So the earthquakes are not over yet, folks. And, you know, we just saw an increase in the proton flux. So there seems to be a 1 in 100,000 chance that there's no correlation between high proton flux levels and earthquakes. So understand that. And again, there's the largest of the past 24. It's a 6.1 magnitude at Chile. Quite near the coast. And we see much deeper inland quakes there regularly in South America as well, on both the east and west side of the Andes Mountains. Next, looking at this deep quake here at Fiji, it's a 4.6 at over 560 kilometers. And then shortly after, less than 2 hours later, a 5.5 west of that big quake, that deep quake. Kermadec Islands region sees a deep quake. Very close to the Fijian quake we just talked about. Oh, no, wait. Anytime now. Come on, USGS, you can handle it. Nice. And let's try that again. A deep quake at the Kermadec Island regions south of Fiji. A 4.5 magnitude at over 390 kilometers depth. A deep quake at Argentina. A very shallow quake at Hawaii. It's at a depth of negative 1.8 kilometers, 1,800 meters above sea level. And this one is under Kilauea, it looks like. Mauna Loa. It's under Mauna Loa, but no place near a caldera, but at a significant altitude. Again, 1,800 meters above sea level is a shallow quake, to say the least. Next, looking at nullschool.net's jet streams map. It's the 250 hectopascals animation. There are the jet streams of the Western world. I would note some Southern Pacific jet stream moving due east to west right here. Here are the jet streams of the east, I think. There we go. And that anticyclone still over the North Central Asia region. Next, looking at windy.com's pressure maps. We'll advance this via the GFS forecast into tomorrow. There's where we expect pressure to be tomorrow at 2 p.m. Universal, 2 p.m. Eastern Daylight Time, Eastern Standard Time. I don't know what I'm talking about. And this map is not being cooperative today. There's where we expect things to be at 1 p.m. Eastern Standard Time. All right. Jeez, what a train wreck. Next, we're on lightningmaps.org. There's where lightning stripes are never mind. Here's the U.S. lightning mapper, the GOES 16 lightning mapper. And it looks like Oklahoma and Arkansas recently saw some significant lightning storms. How about some value-added services? Here's a U.S. Doppler radar map courtesy of Weather Underground. Some more snow falling in Pennsylvania, as well as a long line of rain reaching about from the Pennsylvania-New Jersey border all the way down to northwestern Texas in the Stovepipe, as well as some significant snowfall in Michigan and Wisconsin and Iowa. Shout out to our Great Lakes region viewers. And here's a U.S. water vapor map. And we'll zoom in on this region over Indiana. And here you can see some dry mass of air giving a little boost, giving a push to that moisture there. Although that moisture is moving in a line, so you may see some extended rainfall on this Sunday, November 22nd. And stay tuned, folks. We've got bonus features, and we would remind you to please keep your head and arms inside the smash plane at all times. Today we'll be showing you the 131 angstroms. Actually, you know what? We're going to do the 1700 angstroms view. It's a 2-day SDO video. We're going to show you the intensitygram and the colorized magnetogram as well. So here's the colorized magnetogram, and you can see sunspot 2783 has stayed pretty stable here over the past 24. No big changes there. Sunspot 2784 has grown a little bit. It remains a beta class sunspot, and here's this active region. Very likely to be a sunspot, and we may even see Aurorae. Let's check and see. And indeed we do. There's sunspot 2785. That will most assuredly get a name today. There's a great view of that. Sunspot 2785. Welcome to the sunspot list. Welcome to the solar system. Cheers. Thanks, viewers. There's sunspot 2784, and here's sunspot 2783. Looking triangular, another indication that perhaps Frito-Lay is trying to take over the solar system. And here's the 1700 angstroms 48-hour video from SDO. Thanks for tuning in, folks. It's about that time. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Visit our sites. Please support the channel if possible. And may that solar wind be at your back.